Okay, thank you, thank you. Okay, entonces now you convert as always to exponential statement. You put the arrow, you see, I want to change this statement to exponential because I need to understand much better exponential. Okay, I know that the base is 14. I copy big 14, no small 14. The exponent is 1. Okay, by the way, you know it's invisible. S equal, the rest is x plus 5. Okay, this is the conversion to exponential. In this case, actually, this exponential is no exponential because the exponent is 1 and look like a quadratic equation. No? You distribute the property here. We have x squared plus 5x. And you write our equation in standard. And standard, maybe you, for example, you copy x squared plus 5x minus 14 and move 14 to the right equal to 0. If you feel more comfortable, you interchange the term in the equation, and this is my equation, nice, expressing standard. Okay, so we are expert doing that. We have no problem. Maybe quadratic formula or factorization. In this case, I suppose that factorization is easier and fast and quickly, and the combination is 7. Because 7 times 2 is 14, and 7 somehow minus 2 is 5, and plus 7 and negative 2 equals 0. You break it down into linear equation. The first one is x plus 7 equals 0. Therefore, x is equal minus 7. And x minus 2 equals 0. Therefore, x is equal. And remember, mandatory. In this kind of equation, you need to check in the potential solutions, que es negative 7 and positive 2, in the original equation. So this super important part, checking. Check at 2 and check at negative 7. Okay, you know, guys, negative 7 doesn't work because si you plug in negative 7 here, logarithm of the negative numbers is out of the domain. So I know, negative 7 is a stupid solution. Okay, but let me check in 2, just in case. Let's plug it in 2 in the original equation. This is my original equation. Look, I need to prove somehow by hand or calculator the logarithm of 2 plus 5. Okay, base 14. Don't forget it's no standard. It's the non-standard logarithm of base 14. Wow. It should be equal. I claim this statement because I am not sure if it's true or false. 1 minus logarithm of base 14 of 2. Okay. So now what possibility is, well, you can manipulate. This is mathematics. 2 plus 5 is 7. So logarithm of base 14 of 7 is equal 1 minus logarithm of base 14 of 2. Well, exactly the same we are doing here. I move this logarithm to the same side. Well, it's not illegal, it's possible. Plus logarithm of base 14 of 7 of 2, sorry, equal 1. And you condense it. Using one more time the property number 5. When you condense it in only one, we have logarithm of base 14 of the multiplication. Okay, 7 times 2 is 14. Wow, look at that. And you know very well the property number 2 that we studied. When you have logarithm of the one base and the number inside the argument is the same of the base, the answer is 1. And this is one particular example. System is completely true. That means the solution 2 is perfect. And the solution, the only solution that we have in this equation is 2. Any question? Any question? Do you understand this or no? This example was clear or was confusing? Come on, opinion. Clear or confusing? It's easy to answer. Yes, professor, or no? Or put the sum up.
Here.
Clear, okay, super. Everyone, good. Let me erase the board. I have another, a little bit confusing, because it's 1/3 logarithm base 2 of x plus 6 is equal logarithm base 8 of 3x. Wow. Okay. This is very confusing because in this case we are working with the two logarithms with a different base. So we cannot apply the property. Property number 5, no. Property number 6, no. Property number 7, no. So we apply when you have the same base. This rule or this property is valid only when the base is the same. The only property that we can apply is the property number 8 is the chain of base. Let me record. Property 7. Say, logarithm of base 8 is arbitrary, no? The one expression that I want to call x. Okay, doesn't matter. Is equal logarithm of the another base of x. I change the base from a to b divided by logarithm of base b of x. It's a formula. So we have several possibilities to solve this. I don't know why I like, for example, this logarithm stays the same, base 2. Here I manipulate this guy in order to convert to the base 2. So we have the same base. Oh, this is nice. Okay, I using my formula. Look, this formula. Well, this is logarithm of A8 es 8. Entonces, logaritmo, pero base 2, que es B. Because I want to change from A to 2. This is A in our example. This is 2 in our example. And this is also 2, no? Logarithm base 2 of the expression in the formula put x, but actually in our example no x, it's 3x, no? Divided by logarithm base 2 again because it's the same number of the base, the old base is 8. Do you understand the transformation or no? We're using chain of base formula. Allow us to change the base that you have and another base that you don't have, that you need. Okay? Now, I need help. I want to compute this number, that number. Logarithm base 2 of 8. Okay, this is a number. I know it's a number because no, we have no variable, we have no x. It's just a number. And remember, we have no excuse to don't know how we compute it because we have two possibilities. Do it by hand or using the calculator, no? Entonces, the way you prefer, calculator or by hand. If you, for example, make a decision doing by calculator, the only thing that you should do is using the standard logarithm, that is log of 8 divided by log of 2. So one more time, we're using the chain of base formula, but in another direction, using common logarithm base 10. And you put in the calculator and the answer is 3, for sure. Another possibility is doing by hand. The student can prefer by hand. Well, you don't know, you put x, you convert to exponential. You convert to exponential. When you convert to exponential, you have the base is 2, look at that. The exponent is the thing I don't know. It's equal 8, but I know that a is 2 to the third power. Entonces, if you have 2 exponential and the base is the same, it's because, etc. Correct? Okay, therefore, under this analysis, we have logarithm base 2 of 3x divided by 3, because this guy is 3. Everyone follow me so far? Calculator or by hand? Either way. Okay, now we continue. Solution. Okay, I saw here 1/3. I saw here divided by 3. That's the same stupid thing, right? If you multiply the entire equation by 3, but of course that part, this is cancel out, and this is cancel out. Actually, we have logarithm base 2 of x plus 6 is equal logarithm base 2 of 3x. Wow, super easy. And similar situation happen here. If we have two logarithm function and the base is the same, it's because the argument is x plus 6 is equal to 3x. And you mentally delete that. I don't like to see this line delete. No, no good. But this technique, mentally. Okay, now super easy equation is 6 is equal to 3x minus x. 6 is equal to x divided by 2. X equal to 3. And this is my potential solution I need to verify in the original equation. Always mandatory checking in the logarithmic equation. In the exponential, no. Why no? Because I know that the domain of the exponential is a real number. That means exponential accept any value. Doesn't matter if it's positive, negative. Pero el logaritmo es picky. Logaritmo only accept value of the positive and not 0. Okay, they're checking at 3. Plugging in the original without transformation. Exactly the problem gets given. You put 1/3. Logarithm base 2 of 3 plus 6 should be equal logarithm base 8 of 3 times 3. Okay, entonces 1/3 logarithm base 2 of 9 is equal logarithm base 8 of 9 again, because 3 times 3 is 9. Entonces one more time, if you want checking by hand, you apply one more time the chain of base. So for example, you don't touch that part stays the same. And you now change the base, apply the chain of base formula one more time. So I put logarithm base 2 because my intention is chain base 8 to 2. Divided by logarithm base 2 of 8. Okay, prove before get 3. So we have 1/3 is equal log of 9 is equal log of 9 base 2 divided by 3, que es obvio que this statement is true because it's identical. Entonces the solution is 3. X equal 3. ¿Super o no? ¿Super o no? Good. Any question? Say no? Good. Okay. Okay. As always, you know, in the review package, we go over again to the solution for this kind of question, no? One more before the review. This one, look. Log of 3 plus x minus log x minus 3 is equal log of 3. Well. I don't understand something, professor. What is the base here? The base is missing. So when the base is missing, I know que es 10. Right? Default. No necessary specification 10. Because you know default que es 10. Okay? And you move everything que contain logarithm to the one side. You can, pero no, not necessary. For example, you condense in this and this. You condense this and this in only one logarithm. But I know the subtraction, y si es subtraction es division, es 3 plus x then you put the positive in the top and the negative in the bottom. Don't forget the parentheses. Es equal log of 3. Entonces, in this moment, if we have two logarithms, and the base is the same, it's because the expression inside the argument is 3 plus x is equal x minus 3 equal 3. Wow. And you convert the complicated problem in one super easy problem that do not contain exponential logarithm. No, nothing. It's just elementary algebra. I propose you apply cross multiplication. So 3 plus x times 1 is 3 plus x is equal 3 times x minus 3. You apply this trivial property here, 3x minus 9. Okay, let me finish. For example, equal sign. 3x stay here. Why not? Minus x can move to the right. 3 stay here. Plus 9 is moving to the left. Hey, noise. Where's the noise? Is it 12 is equal? Danny? Thank you. This is 2, no? 3 minus 1 is 2. Divided by 2. X equals 6. Boom. And this is the answer. No, I don't know. I need to check it. Mandatory. And when you compute in the logarithm equation, one solution, you need to check it in the original equation. But it's easy. You declare x equals 6, I'm plugging it in the original. I need to prove somehow the logarithm of 3 plus 6 minus logarithm of 6 minus 3 should be equal logarithm of 3. I don't know if it's true or false. Logarithm of 9 minus logarithm of 3, because 6 minus 3 is 3, should be logarithm of 3. Okay, there are many ways to prove that. You want, again, similar to the solution, you condense this and this in only one. Is logarithm of 9 divided by 3. Subtraction equation. It's obvious que es logarithm of the 3 because 9 divided by 3 is 3, it's exactly the same on the right hand side, super true. And the solution 6 is correct. Boom. Final answer. 6. End story. Any question? Clear or no? Okay, today, and the time that we have, we start applying now application. Because in this moment, we know everything about solution of the exponential equation and logarithm equation. So now I want to propose you some problem of the real life que somehow involve application for the logarithm and exponential. No? So let's do a solution, the typical is the same that you can see in Alex, and you can see in the review packet and in the test. Okay, the first one is the investment. O sea, it's the problem of the compound interest. Compound interest. Okay, it's super easy. O sea, you have, for example, one money. I want to call P. Why is the reason it's P? Because it's present value. Present value. This money you have now at T equals 0. And you deposit in one bank account, of course, saving account or CD account, no checking account, no, because you need interest. And now, see, you never, during some years or some month, some period, you don't withdraw the money. No, okay, your money increasing. And your money increasing, I call capital A, que es future value. Future value. At T equals something. So what is the formula? Well, we have different formulas and depending of different parameters. Okay, the first formula is future value is equal present value 1 plus R over N raised to the NT. Let me declare who is this guy. Who is R? R is interest rate. Okay, normally, the bank, they declare, for example, APR. APR is annual percent rate. Normally, it's a present percentage. Okay, the bank is 3% APR, or whatever. Never more than 3. This is according to our economy now. Is no. Pero bueno, interest rate in general. Mathematics is interest rate. Percent, pero let's see how we manipulate the formula. Who is T? T is the time. The time always in years. Okay, suppose I want to know how many dollars we have in 10 years. After when you create the account, in 10 years, how many dollars increase in my money? Okay, T is equal to 10 in years. And the most complicated part is M. M is compounding. This is the idea for the compound interest. No? Compounding. Compounding is a number que you know is equal 1, so N is 1. See our account increasing annually. Because what is the idea for the compounding? The money, you know, increasing like 1 stairs, like that. This is the time. This is the money, future value. This is the original time equals 0 as a P. And my money increasing like that. Boom, 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 boom. Suppose get more money, the step is large. But increasing. So this period, this amount of time, maybe it's annually, see N is 1. See the account, when you set out the account, and when your banker, you say, well, okay, it's 3% APR. Compounding annually, of course, annually. Okay, no problem, I understand. See SN equal to semi-annually. Semi-annual. That means que cuando es 2 es because in 1 year, suppose que this period is 1 year, 1 year, 2 years, 3 years, the money increasing 6 months, 6 months, 6 months, 6 months, because it's 2 times in 1 year. So basically, the idea for the compounding is how many times our money increases in 1 year. Another possibility is N equal 4 is quarterly. Quarterly. Don't worry for this because in the word problem is clear what is the compounding, no? In the real life, in the word problem indicate, well, our account is quarterly. Our account is monthly, it's 12. Monthly. Our account is weekly. It's 52 because, you know, okay, 52 weeks we have in 1 year. Or daily is very, very crazy. But well, it's mathematical possible. It's 365 days. This is daily. This is the formula that we are using. This is the formula that we are using for the compound interest. And this formula we can modify a little bit. Because maybe sometime in the real life we know very well the money that you need in the future, and you need to figure it out what's the money that you need to deposit now in order to get. Suppose I want $1 million. How many dollars you need to deposit it now? See, in 30 years I need the $1 million. Entonces now the condition for the account is clear. The condition is I don't know, semi-annually, interest rate 5% because it's CD. Okay, entonces one formula que derive of this is the formula for the present value. The present value, when you need to know the future value that you need to get, is similar. But the only thing you should do is divide by this. Is 1 plus R over N raised to the NT. Okay, this is similar formula expressed in a different way because in this case I need the present value because I know the future value. And this is the typical example. However, we have another possibility, not exactly in the bank account. So you, for example, you can estimate inflation or you can estimate some indicator, for example, what is the price of the stock market of the Apple Corporation in 2032. So you have no idea because the interest is variable. This we're using another formula, que es the formula que is called continuous. So this is discrete. Discrete. Because the money increasing like stairs. But so you have no idea about these stairs, you suppose que es continuous. And vary according to the another formula, que es the formula for the exponential. The formula is future value is equal present value e to the RT. Okay, no compound, because I suppose the compound, I suppose que M is infinity. This is continuous. Likewise, the formula for the present value is future value e to the minus RT because this is negative exponent because there's division. Now, basically, we have 4 formulas. Future value formula, present value formula, discrete problem, and continuous problem. Future value and present value. Okay? Let's see application. Let's see application. Do you understand the idea or no? Or no? Or confusing? Completely confusing. You understand or no? No? See, yes or no? Good. Okay. Super. Okay, entonces I sent to you today one PowerPoint. This is the same PowerPoint I want to contain the problem that I want to solve in today. Next lecture, Thursday, no? Today is Tuesday. Okay, PowerPoint. Let me try to find PowerPoint document. Wow. PowerPoint. There you go. Is application logarithmic. Okay. Okay, there you go. I start doing this. Look. You see very well? This is super easy. Dice, if $10,000 is invested in account at 3% APR, compound quarterly price given, how much money will be in the account in 5 years if no money withdrawn? Boom. Information gets given. Information gets given. It's given present value. The money I have right now, 10,000. One more information. Oh, interest rate R is 3% APR. But in the formula, never we use in percentage. You using in decimal, 0.03. You divide by the conversion, the classical conversion percentage to decimal, divided by 100. And divided by 100 is equivalent to move the decimal point 2 places to the left. 1, 2, 0.0. And the formula, never percentage. In the language, when the people speaking, yeah, it's clear, more clear percentage. But in the formula, the compound quarterly means that N is 4. Because of 4 times 1 year, quarterly. How much money will be? To say the question is future value. I have no idea. What is the future value? And the time is 5 years. Okay. Everything is clear. I take my formula. Future value is equal present value. 1 plus R over N, because the problem is discrete, it's stairs. My money increasing like stairs, and this is stair, each step of the stairs is for 3 more. So quarterly is 3 more. Empty. This is my formula. Okay, now future value is equal to 10,000. Parentheses 1 plus 0.03 divided by 4 raised to the nt. What means nt? It's a multiplication. M get 4 and t get 5. Actually, the exponent is 20. Where come from 20? Was the multiplication n times 5. And this is logical. This is logical because actually we have 5 years. Look at that. 1, 0. 1, 2, 3, 4, and 5. But each year you divide in 4 periods, quarterly, like that. Okay, so we have our money increasing like that. Boom, 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 boom. This is 1 year, 4. But 4, 4, 4, 4, and 5, and 4. So 4 times 5 is 20 period. That is the reason that the exponent is 20. It's like an exponential formula using exponent 20, right? And the rest is calculator. And calculator, you put in the calculator. I encourage everyone, please help me. Put in the calculator 10,000. So the syntax is look. Suppose that this is the display of the calculator. Okay, and you write 10,000 first. Open the parentheses. Open the parentheses. Inside the parentheses, you put 1 plus 0.03 divided by 4. Like that is 1 plus 0.03 divided by 4. Close the parentheses. You put the symbol of the power. It look like that. 20. Power 20. Power 20. I press enter. Bam. You get the answer. Who get the answer? Come on, help me. Remember, this is currency. It's a money. So you round to the 2 decimal place. I get in my calculator $11,611 and 84 cents. It's the money you have. In 5 years, and your account start in 10,000, increasing to 11,611.84. Any question? Any question? Any question? Go ahead. Activate the microphone. Question. You need extra explanation? Super clear? Come on, guy. What's going on? Clear? Good. Okay. This is easy. Clear. It's the first. Yeah, I know it's easy. It's the first example. But I want to complicate more, of course. Okay, erase the board. And let me unlock again the PowerPoint. Come on. PowerPoint. Come on. PowerPoint. There you go. Application logarithmic. Let's move on to the second example. I put 1 by 1 because you know. Okay, second example. Boom. Oh, look at that. It's about the car. It's about the car. It's John. John wants to buy 30,000. I forgot 1 0 here. 30,000. Okay, 30,000. No. This is wrong. I need to check it there. Carajo. the $30,000 is the price of the car. However, the strategy of John is he has saved 27. Okay, almost. However, he deposited in the account, in one saving account. Find the number of years it will take to his, look at that, I fixed that. His $27,000 to grow to $30,000. And the account the bank proposed is compoundedly is compounded is quarterly, and the interest rate is 4%, que es equivalent decimal 0.04. Entonces es obvio que this is the future value and this is the present value. Make sense or no? Make sense or no? Make sense or no? Okay, she won, or he, 30,000 to buy the car. He has physically today, right now, 27. He deposited the money because the money, this is the beauty of the compound interest. The money working for you. The money increasing by yourself. You don't need to work no more. The money increases, work for you. Okay, now the account the bank proposed was 4% APR compounded quarterly. Okay. And what is my unknown in the formula? Okay, what is my unknown? Let me copy my famous formula. My famous formula is future value is equal present value 1 plus R divided by M and T. This is my formula. I know A, boom. I know P, boom. I know R, boom. I know N, boom. What is my unknown? It's T. It's exactly the same, the equation. Find the number of years it will take to the money increasing. So I need to solve for T. Okay, easy. Do you understand or no? Do you understand or no?
Yeah.
Yes. Now,
Yes.
let's, good. So let's do it. I have no idea. Si es logarithmic equation, si es exponential equation. I suppose que es exponential. But I don't remember that they are exponential equation that you solve using right. Okay, I have an idea. Totally lost. You just plug it in. Who is A? 30,000. Who is P? 27,000. Paréntesis. 1 plus 0.04 divided by 4. Oh, nice. M que es 40. The only unknown is T. I need to solve for T. Well, it's easy. You divide. For example, you divide both sides by 27,000. This is cancel out and cancel out also 30. Here I suppose que es divisible by 3, no? Because this is 30 divided by 3 is 10, and 27 divided by 3 is 9. It's 10 over 9. Okay. And the other side, when this part disappears, we have 1 plus, look at that, easy. 0.04 divided by 4 is 0.01. Raised to the 40. Little by little, you apply your knowledge of the algebra, and you try to solve for T at the time. Okay, and now why not? There are no reason to have separately here. 1 plus 1, 0.01 is equivalent to say 1.01. Raised to the 40. Okay, now this is the exponential equation. I know. However, it's complicated doing in the traditional way. Better you apply logarithm. What kind? Standard. Put in the calculator. And in my paper, I don't know why I put ln. But if you apply log, the answer doesn't change. This is ln 1.0140. Let me continue here. We apply now one more time the famous property number 7 que allow me this exponent put in the front as a factor. So we have logaritmo 10 over 9 is equal 40 ln of 1.01. Finally, if you want to solve for t, you divide both sides by 4 ln 1.01, both sides, of course. 4 ln 1.01. Okay, so the answer is ln 10 over 9 divided by 4 ln 1.01 is equal to t. But okay, leave it like that. No, hello, what is that? It's crazy. I need to know how many years, 2 years, 3 years, 4 years. Okay, so I put in the calculator. Of course, I put in the calculator this expression because I want to compute how many years. Suppose that this is the display of my calculator. You type in the key ln. Automatically, when you type ln, open one first parenthesis. And you put 10 divided by 9 and close the parenthesis. I finish the top one. Divided by division key. Very important this detail. You open one new parenthesis because I need to enclose everything in the denominator. Because you omit this parenthesis, the calculator is not smart. The calculator understands that divide by 4 and multiplication by logarithm is wrong. It's 4 times period, time, the calculator is time, like that, ln 1.01. Close the parenthesis of the logarithm and close the parenthesis again, close everything in the denominator. And now press enter or equal. Let's do it. Come on. Let's put in my calculator also. Natural. 10 divided by 9. Close the parenthesis. Division. Open new parenthesis. Important this parenthesis. 4 times. ln 1.01. And close to parenthesis. Boom, boom. Press enter. Got it. The answer is 2.647. These are years. So approximately, to have intuitive idea, I need to waiting for the money increasing to the price of the car. I need 3 years. You round off 3 years, and 3 years the money is enough. Buy the car. 2.6 is a little bit more than 2.5 years. So approximately in 2 years and 8 months, maybe 7. I don't know exactly. You have the money. Okay? Super clear or super confusing? Let me see your opinion. Your opinion is important for me. It's clear. Okay. Okay, let's do one more example. Okay, I want to erase everything. Okay. Let me again upload the PowerPoint. Good. This is example 3. We are doing every problem in the PowerPoint. No, not necessarily today. We continue next time. And we start review package. Problem number 3. Boom. Look at that. This is easy. It's also compound interest. So you expect in the test, of course, a problem of the compound interest, no? Find the future value. Find the future value. Future value. I need to find the future value. I don't know. That result from invest the present value. Present value is 2,000. At R, is interest rate 0.08. Compounding continuously. Wow, continuously. Continuously is different formula. Because the formula for the continuous is future value is equal present value exponential using ERT. It's a formula because it's continuous. continuous. And t equal 1 year, y en 10 years. O sea, two answers we need. Okay, let's do it. The formula is easy. The formula is, look, future value. Suppose t equal 1 year. Year, no yard, years. Is future value is equal 2000 exponential, and exponent I put 0.08 multiplication by 1. How you put in the calculator this? Say again? You talk to me or no? Putting off microphone, guys. How you put in the calculator like that? Well, you put 2000. Entonces you press. I suppose you have one calculator similar, like my calculator, que es TI-30. Entonces, in the same key, remember that we studied last time, que we have two keys. I don't know if I have or not the picture of the calculator here available. Yes, look at that. This is the calculator. Look. This is exactly the same the calculator I have in my hand now. Okay, so you see que we have two famous keys, que es L or G, this key, and LN. However, this key have double function because in blue color, depending on the calculator, in blue or in yellow. So you press the second key. Second, to say now you understand que es the second function, is the blue function. Because I need, when I put 2000, let me see, 2000, I clear display, I put 2000 multiplication times symbol, time. And now you put exponential. Exponential is the key second and the key of the ln. So that key after you press this key. Entonces you have in this moment, let me see, second ln, you see something like that. Exponential, the star symbol, and open the parentheses. It's equivalent to this. And inside the parentheses, you put 0.08 times 1 and close the parentheses. 0.08 times 1 and close the parentheses. And present it. Boom. The answer is, look, the answer is, in this case, is $2,166.50. Okay, this is 1 year. The exponential in 1 year, and 10 years should be bigger, right? That's you left the money in the account. Your money increasing, in this case, increasing faster because it's continuously. But the same formula is 2000 exponential. Then the exponent you have the same interest rate because it's the same account. The only thing it changed is the number of years you withdraw the money in the left the money in the account. Okay, so now it's similar, except instead of 1 here, it's 10. So it's the same. You repeat. Go ahead. Somebody have a question in the chat? Let me see. Question in the chat. You see something? Okay. I recommend you activate the microphone. Okay. Oh, you get the answer. Okay, super. Dylan, give me the answer. Dylan, give me the answer. The answer is $4,451.08. Everyone is agree or disagree? It's important, guys. Can you try to verification in your own calculator this computation? Because in the test, I cannot help you. Now I can help. Do you have any problem? Thank you, Dylan. I did in my paper, right? I have this answer in my paper. However, I want to verification of the calculator, but no. I trust you. You are doing well. Any question? Any question? Any question? Let's do one more. Let's do one more. Let's do one more. Dylan is typing. Okay. Why 12 and not 10? Why 12? No, not 12. It's 10. Why 12? All right, let me see. I make a mistake. Oh, yes. I'm crazy. It's 10. This is 10 here. I am crazy, totally. 10. Yes, but the answer doesn't change because the answer I computed with. Yeah. Okay. Any other question? No problem. Any other? Got it. Okay. Beautiful. Let's see one more about compound interest. Let's see one more about compound interest. Okay, I want to raise the board. Let me upload again the PowerPoint. Okay, application logarithmic is number 4. This. Boom. Okay, this is about, another kind of investment, and the word is buy bonds, question mark. It's another possibility, no? But the bond is more safe, because you never lost money. And you increase it, not too much, but you increase it. So a bond can be redeeming in 10 years. What mean that? Okay, it's like a maturity time. You buying the bond now, one price. Entonces, en 10 years, you receive the money, que es equivalent, but it's bigger than the money you spent in the bond at the beginning. No? How much should be willing to pay it now if you want to return 7% compound monthly, 6%? So we have two problems. Problem number 1 and problem number 2. Okay. Entonces, what formula are we using? Well, you're using the formula for the present value, no? Because, wait. I assume that the future value, so I have no idea, but I assume that the future value is 1,000. Bueno, in the test, the information is clear. Maybe here I omit this area. I suppose I need to get 1,000. So the challenge is how much I am willing to pay now. I pay 500, I pay 600 for the price of the bond right now. Okay, entonces now the formula that we are using is the same formula que es P, pero the formula for the present value, because I know the future value, the money I need to get in the future. It's similar, the only que the exponent is negative, 80. Entonces, in the first scenario, well, in the first scenario is 7%, R is 0.07, que es this guy. The time is 10 years, que es the maturity time of the bond, 10 years. Okay, and compounding monthly, n equal to 12. This is the condition for this guy. Okay, super. Plug it in. P es simple. A, que es 1,000, I assume. Well, this information should be given. The price, the money you want to get is this money. Es 1,000. Entonces 1 plus 0.07 divided by 12, because the compounding is 12, and the exponent is negative. You know que es negative. The multiplication in T is 120. 120 exponent. Okay. I put in my calculator. Guy, help me. Everyone, put this expression. How you put in the calculator something like that? Well, I put something like that. I put 1000 multiplication parentheses 1 plus 0.07 divided by 12, close the parenthesis, power, parenthesis minus 120. It's important this parenthesis because if you omit this parenthesis, the calculator believes it's subtraction. No, it's power. But the exponent is 120. Let me try to do my best. It's 1000 multiplication, open the parentheses, 1 plus 0.07 divided by 12, because it's monthly, close the parenthesis, power, parenthesis, minus, pero no minus of the subtraction. Remember, any calculator has to minus. One minus is, in my calculator, blue color, is subtraction. No. I'm using the minus of the minus value, que es negative number, negative 120, que es white color. Okay? Entonces, minus 120. And close the parenthesis, the last parenthesis, press enter, boom. You get the answer. The answer is, some people get the answer or no? Let me see in the chat si some people get the answer or no. A ver, yes. Again, Dila is the mathematician. It's $497.59. And 59. And 59 or 60. Let me check. Dila, much better round to the 60 cents because it's 59.6. Do you hear me? At least in my calculator, I saw. At least in my, oh yes, sir. Okay. Okay, so the answer is $497.60. This is the price of the bond. Now, in the present. When you buy, spend your money. In the future, boom, you get 1,000. This is the idea. Let's do in the second part of the problem. The second part of the problem is, it's the same. It's the same, but it's compoundly. It's continuously. And continuous means that the formula is different. The formula is present value is equal future value exponential minus RT. Okay, in the display of the hour calculator, I put something like that. 1,000, okay, time exponential. Let me put in the calculator. 1,000. Clear. 1,000. Time exponential. Exponential, remember, is the same key of the logarithm natural. But you press second, and you get the blue function, is E power parenthesis, and inside you put the R. The R is, in that case, is 6% in decimal 0.06. And you put 0.06 multiplication by 10. Remember that the time is 10 years. Multiplication by 10. And close the parenthesis, I guess. So, is 0.06 times 10. Bam. No, I make a mistake. I make a mistake. It's 10. It's 10, 0.06, pero es negative. Oh, I forgot the negative, carajo. I forgot the negative here. I forgot the negative. Okay, let's do it again. 1,000 times exponential. Negative, of course, y negative. 0.06 times 10. Close the parenthesis, present. Bam, I got it. The answer is 548 dollars and 81. 81, yeah, 81 cents. It's important that you apply common sense and your imagination and try to understand the problem, no? Because in the test, normally you see comparison to situation. In this case, suppose I have two offers. 7% compound monthly and 6% compound continuously. it's obvious that the best option is this. This is the best because the present value is smaller. Okay, to say you spend only $497 and you get in your money in 10 years 1,000. No? In this case, the price is bigger. So this is the best option. Clear or confusing? All right. You have opinion in the chat? Sir, this is one rounding, yeah, of the same. Yeah, yeah. Always, when you're talking about money, you round off to the nearest cent because it's currency. Money. Don't have sense to talk about a fraction of cent. No, this is stupid. Okay? Any other question? Any other question? Okay, no problema. Okay. Let's move on. Yeah, this is the problem I bring about compound interest. We have another application. We have another application of the exponential equation and logarithmic en biology, en physics, y en physics, biology, physics, chemistry, maybe, yeah, and also in another application for example, propagation for the pandemic is exponential equation also. You can simulation the propagation, how many infected people we have, but no. So I bring one problem of the biology. Okay, let's see the biology, and that's it for today. We continue the physics and chemistry next class. Okay, look at that. PowerPoint. Application logarithmic. Wow, too delay. This one. Wow, it's interesting. It's about insect. A certain insect population growth according to the law of the uninhibited growth. Okay, this situation happened in the small organism like a bacteria, virus, insect maybe, and what the population increasing according to the exponential, because exponential is like an uninhibited growth, because I suppose we have enough space and we have enough of food, and the microorganism increasing without limitation, no problem. Space, food, only need. No happen in the human being. Human being, no. Human being is a little bit crazy. The human being, you see the population of the human being in the earth is exponential. No, it's not true. It's completely wrong. Because the human being, they are competition. They are war. Envy. There's no increasing exponential. No, these are animals, virus, bacteria is really stupid. Need only food and space, and that's it. Entonces, uninhibited and uninhibited exponential, classical exponential. According to the problem, the initial amount of the insect F500 and growth up 611 in 10 years. Wow, too fast. How many insects have an amount? Okay, let me try to understand this. What is the formula for the exponential growth? Exponential growth is population at any time is equal P null. What means P null? Initial population. In our example, is 500. So always at the beginning say something, 500. E is exponential, exactly the same. The exponent in the calculator, E RT. It's a formula. Super easy. So we're using that formula. What the information do we have at the beginning? P null is 500. We have also another information that is P evaluated at 10 years is 611 in set. Of course, increasing, not too much, but increasing. No? And my question is, what is the population in 30 years? Okay, it's 1 month. This is the idea. Do you understand this? This is my formula. This is a MAC condition. I can visualize the problem like that. Look. You understand or no? No? Confusing? You say yes? Yes. Okay. Okay. Yes. Okay, let me clarify a little bit more. This is a graphic. This is the time. The time, by the way, the time is in days in this program. No, always happening. Sometimes it's in years, sometimes it's in century, month. At the beginning, get t equals 0. We have 500 something in set. Okay, now at t equal 10 days, suppose 10 here. The population increasing to 611. So we have 1 point here, we have 1 point here. You need to investigate what's going on in 30 days, because 1 more. I suppose increasing more, no? I suppose so. I have no idea. This is my graph, suppose. Yeah, I need this number. It's my own number. This guy. This is the population, this axis, so number of the insect, and this is the time. Okay? More clear this picture. Remember, one picture is much better than 1,000 words. I explain. Nobody understands anything. Okay, I propose you stop today because it's a little bit complicated. And we continue next time, right? Everyone is clear? What is the famous day in our subject? December 9, is due test 4. December 13, final. By the way, I will send both simultaneously. So when you have, so before December 9, you have in your hand both tests. Test number 4 and final test. And you are doing simultaneously. And send me to me before the due date, and you have no problem. Okay? Okay, guys. Time is over. Have a nice good day. Good night for everyone.